Shaded region. When we do shaded region stuff, just like we have in the past, what we're looking at doing is finding the area of the large object and subtracting the area of the small object. Therefore, what's creating the shade, okay? Now, when we get into a lot of these things, we're gonna be looking at circles with regular polygons. We're looking with regular polygons with circles, with sectors, and it just mixes a lot of stuff together. So what we have to be able to do here is just identify parts, know how to draw specific things, and go from there. Now, in this case, we have a, what is that, a five-sided figure, which is a pentagon. We have a pentagon cut out of a circle. So what we have to be able to do is we have to, first of all, find the area of the large object. Well, the large object here is a circle. When you find the area of a circle, you have to know its radius. Now, in the pentagon, though, we're given a side plane. Well, in order to find the area of a pentagon, you have to know its perimeter and its apothem. So there's a couple of things that we have to work towards. So think about what a radius is in regards to the pentagon as well. Isn't that one of the features that we draw when we put in our three sides? Yeah. Exactly. So once again, we'll start by drawing our three sides. The whole thing is 12, a 6, and a 6. Take our 360 divided out by the 5, and that'll give me 72, I believe.
Yeah, and then the interior.
Exterior angles. Okay. Excuse me. So we know that the exterior angles are all 360. Divide out by the number of sides, you'd be at 72. The supplement would be 108, but remember that 108 gets cut in half via the radius. Well, so half of 108. All right.
Sorry.
There's a lot here. Okay. Now you've got your triangle to work with on the inside. And hey, it looks like every other problem that we've done. We need to find our apothem, and we need to find the radius. That radius is the hypotenuse of the triangle, and the apothem is one of the legs. You know one side length, which means you're going to use two different trig functions to figure the rest out. Which trig function will get me my apothem, knowing that I have an adjacent? Tangent. What trig function will get me my radius, knowing my adjacent? Cosine. Cosine. Okay. So you have two trigs here. We have the tangent. 54 is your apothem over 6. So 6 tangent. It's not a bad idea. Do you notice how I've done this a couple times now? I've labeled what part I'm looking for with the trig value. See how I threw an apothem in there, just abbreviated wise? For the next one, I'm going to put an R, so that way you remember that's a radius that you're looking for. Same deal. It's cosine of 54 is our adjacent over the radius. What was our trick when the variable was in the denominator? Switch. Exchange-o, change-o. Okay. And now goes to pressing buttons. $8.26. And 6 divided by the cosine of 54. 10.21. And it is important that as you go through these things, you're writing down what things mean, where these numbers come from. Okay? So, area of the circle. Subtract out the area of the pentagon. 10.21 squared times pi minus 1/2, 5 sides of, what was it, 12? Times 8.26, which is your apple.
So do you want us to do like each of those equations separate and just subtract them?
Yeah, I was just about to get there, Jacob. One of my big suggestion here, guys. Notice how I constantly write down what I'm going to do prior to doing it in the calculator? Please keep doing that. You guys, I see so many of you guys are just miraculously coming up with all these decimals and values for areas, but yet you're not showing any work for any of this stuff. Now, I get it. Some of this stuff is relatively straightforward, but I don't know where you're writing it down to figure out what parts go where. Okay? Or that you know how to actually store all your answers within values within the calculators to do all that. There's ways to do it, but I'm pretty sure most of you guys don't know that. All right? So, just an FYI, I start seeing just a bunch of numbers written down on things, you're BSing me. I didn't mean to look at you when I said it, Grace. I'm sorry. I'm sorry. I realized I looked right at you as I did that. Like, sorry, I wasn't implying you. So, then,
This whole time. Ever since we came here.
so that gives me my first one. To that, I would subtract, was it 0.5 times 5 times 12 times 8.26. See how I'm doing that in the calculator, guys? I'm taking care of the first chunk, hitting enter, subtract, parentheses, the next string. Just like I wrote it down. Okay, just like I wrote it down. Gives me an area of 7969 something squared. Bless you. Okay. Now remember, what's happening here is you're basically finding an area twice in one problem. Okay, you're basically finding an area twice, but you have a couple extra steps that are built into it to get there. Okay. It's just a couple extra steps built in. Excuse me. What's that? So now things get a bit goofy. What's the object on the interior? Triangle. Triangle. More specifically, it's an equilateral triangle. Okay. We have an equilateral triangle. And we have a circle that has a radius of 8. So the circle is going to be easy to find. We could probably do the circle part right now. Does everybody agree that it's just 64 pi?
Yep.
Okay. So think about it. You're halfway done.
Whoa.
Madison, put your phone away. You've been gone enough. You might want to keep up with this. That's quick. That's painless. We know that one. Circles are pretty easy. Okay. Getting into the triangle, though, an equilateral triangle, remember what the radius does to the angle there? It bisects it, right? What do all angles inside of an equilateral triangle measure? 60. So what this does then is that it creates a
30, 60, 90.
30, 60, 90. Very good. It creates a 30, 60, 90. Okay. So, ratios of the sides. Or could you use trigonometry to figure it out? Either one of them. Okay. Because if you think, you're trying to find this portion. Because that would give you the whole side length by doubling it. Okay. This portion here is still an apical. It's from the center to the side, the perpendicular bisector. So you can still use either 30, 60, 90 or trig. Use 30, 60, 90, it's a little bit quicker. Across from which of those do you know? The 8 across from the 90, good. So if 8 is representative of the 2x, what's the value of x across from the 30?
4.
4. So that means across from the apical would be 4, and half the side length would be 4 root 3. Is that all right, Pat?
Yep.
Now, if one chunk is 4 root 3, this chunk's 4 root 3, the whole thing is 8 root 3. You now know a side length of the triangle, you know the apicum of the triangle, you know the radius of the circle. All just by using, oh, that's right, big giant review of everything. If you use trig, you'd have to use sine and cosine. You're gonna get the exact same answers, but yet sometimes when you press the buttons on trig, it might not give it with the root 3, it might just give you the decimal, which is fine. You're still gonna press the same. If you round it out, you'll get a little bit different answer as opposed to using the radical in it. It's still the idea of showing how you got the values is what's important. Because there's more than one way to do this. Okay? So we go with area of the circle. Our area of the triangle is going to be 1/2 the perimeter, which are 3 sides of 8 root 3, times the apothem, which was 4. So the overall, 1/2, 8 root 3, oops, 3 sides of 8 root 3 times 4. Pi, hit enter, subtract parentheses, 0.5 times 3 times 8 root 3. Make sure you hit the right button so you don't accidentally stay underneath the radical. Big, big common mistake. And then times 4. 117.92, something squared. 117.92 point something, or 117.92 something squared. It's a matter of piecemealing a couple things together. Okay. Are you ready for the snow cone?
No.
Yeah.
Why can't it be a scoop of ice cream on an ice cream cone?
Because I think when you have a scoop of ice cream, the scoop of ice cream, it's more more round, whereas a
Okay.
snow cone,
It has more of that curve
Yeah.
because of the ice.
yeah.
Just asking just because, you know.
Now you
I
made me
don't
hungry.
know.
Not that you don't like ice cream
I know,
versus,
right?
you know.
What was the last time I was?
You know what? I had a snow cone last summer. We were in Florida, and they were just selling snow cones on, like right by the beach where we were at, and you know, kids and we were like, yeah, fine, we'll have some snow cones. It was great. I hadn't had a snow cone in forever, and we don't feed them to our children because, as you know, children are messy, and snow cones are not the cleanest thing in the world. So
Yeah.
why not let them have it on sand next
And
to an
then
ocean?
Make it go into the water. There you go.
Clean
Smart.
yourself
They actually had one that's when I went this morning to Daytona. And it was
Yeah,
some like kind of cars and stuff.
yeah. There was it Daytona we got? Because we were in Daytona last summer too. And I'm trying to remember if it was in Daytona or if it was Miami. But either or, it was pretty cool that we were. You know, that was the last time I had a snow cone. But you can't beat a good ice cream. I'm with you on that. You can't. So this, if you look carefully,
We are.
oh, Lord knows I can't draw this to save my life. So,
Hey,
but
don't complain.
what I want you to think of here,
I got kicked out of my art class in sixth grade. 'Cause I
Austin, we've already said it a couple times. Thank you. Okay. Now, I know it's not the end of the world if you can't draw stuff. Really isn't. Because what I want you to think of is what exactly created the shaded area. The triangle, but more importantly, if you think about what that was, what is this? It's a sector, yeah. It's a sector, but what was cut out of it? Triangle. It was a sector that a triangle was cut out of, and it left you with just that. So it's like a guy with blue hair. Okay. Got a little patch, yeah, a couple patches of gray thrown in there, yeah.
Mr. Wolf, is he on crack?
Anyway, so again, it goes back to the idea, how did you create the object? Well, the object was made by the area of a sector subtract the area of a triangle. Which means you have to remember how do you find the area of a sector. Well, area of a sector was the central angle over 360 times pi r squared. Okay. Now that 2 root 3 is playing the role of the height of a triangle, and it has a 60-degree arc, which means what's the central angle? It's 60, okay? So when we get into this then, oops, let me try and draw this out here. So here's my 60-degree angle, because this was a 60-degree arc. The height of the triangle was 2 root 3, which means that since this stuff goes through here, this now becomes a 30-degree angle here, okay? And you just mumbled it, it's a 30, 60, 90 again. So we know that we have to figure out the radius or the side length of that triangle to make this work. Now you've got a 30, 60, 90. And you know across from now, the 60 is 2 root 3, which means what's across from the 30? 2. So this is 2 root 3, which means this is 2, and this is 4. So this is 2, and this is 4, 4, and 2, which makes your side lengths 4. Yes, ma'am? Good talking to you. So what's your radius of the sector? 4. The radius of the sector is going to be 4. And now, do I have the base and the height of the triangle?
Yes.
The base is 4, the height is 2 root 3. Or could I use perimeter aptitude? I can do any of that stuff, but I would just go with base and height because it's quicker to it's just a triangle. Okay? So start filling in blanks. Area of the sector was 60 over 360 times 4 squared pi. To that, we have to subtract our triangle. 1/2 base of 4, height of 2 root 3. 16 over 6, 8 over 3, 8 pi over 3. Subtract 4 root 3. Or type it through. Take your fraction bar, 60 over 360 times 4 squared. Oops. There we go. No, it's supposed to be 2. I'll get it eventually.
Last
Okay.
day of school, I should bring a snow cone machine in.
And then we subtract 1/2 times 4 times 2 root 3. $145. Okay, 1.45. Yeah, whatever the unit square. Yeah, 1.45. Thank you for reminding me. 1.45 something squared, and that gets me there. Okay, it's what's that? No, that's the whole area. That's the area of the snow. Because we found the radius by using the special right triangle. And quite honestly, guys, that's about as goofy as this gets, where you have to kind of melt together. Or I didn't mean to say melt because it's snow, but where you blend together a couple of different setups to get you to an answer. Okay, I mean, you could really get goofy going here, but we don't really need to. Sir.
Would you not move later real quick?
No problem. Let's get some problems then.
And I should bring back the snow cone machine.
Remember last year? That's me. I was about. That was. This is a little better, but that I was about to count. Remember that? Yeah, he started running when he chases. Doing it.
No, thank you for being so cheery. All you do is complain. Whatever. All right, let's see here. If I'm not mistaken, I thought I put this on the calendar already. I did not. So let's do this. Yeah, just do this all on a separate sheet of paper. Basically, add this to the paper you started last night.
Just number 20. Oh, just number 20?
I have 7 of them for you. 3 of them you just have to draw. 3 of them are basic. They're not shaded region ones. They're just find the area. 4 of them are shaded region. Of the 4, you have examples of every single one of them. Okay. So you have your guys already go back and forth between your notes, and you will see that you have examples of things that you've seen. Go figure. You do examples in class that will help you on your. I see what you did there. All right. On Monday, we will start with the shaded region of probability. It's a good chance we'll have fun. I'm good.